Hi everyone, welcome back to my YouTube channel. I guess you already know me. Myself, I'm Lokita GS, studying in Shivankeshwara College of Engineering in the second year, fourth sem. Ah, today's topic is like today's topic is properties of groups and subgroups. Today's subject is discrete mathematics. It is one of the subject in fourth sem engineering in CSE branch. I belong to artificial intelligence branch which is in CSE. Okay. Introduction to properties of group and subgroup. Groups and subgroup are fundamental concepts in abstract algebra. A group is a set equipped with an operation that satisfies closure, associativity, identity, and inverse properties. A subgroup is a subset of a group that forms a group under the same operation. Closure property. A closure property states that for any element A, B in a group G, the result of their operation A, B is also in G. Subgroup inherit the closure property from the parent group, meaning that the operation on element within the subgroup remains within the subgroup. Associativity property. The associativity property states that for any element A, B, C in a group G, the operation is associated. That is, C is equal to A. Identity property. The identity property states that there exists an identity element E in a group G such that for any element A in a G, A is equal to E is equal to A, E is equal to 3. Third bullet. Inverse property. The inverse property states that for any element A in a group G, there exists an inverse element A inverse minus 1 such that A inverse minus 1 is equal to E is equal to A inverse minus 1. Your third bullet. Subgroup criteria. A subset H of a group G is a subgroup if it is non-empty, closed under the operation, and contains the inverses of its element. The subgroup must also inherit the identity element from the parent group and be associated under the same operation. Checking this criteria ensures that a subset forms a valid subgroup of a given group. Proper subgroup. A proper subgroup is a subgroup that is not equal to the entire group G. Proper subgroups are essential for understanding the structure and complexity of a group as they represent distinct smaller subsets with their own properties. Proper subgroups provide insights into the subgroup lattice and the relationships between different subgroups within a group. Trivial subgroup. The trivial subgroup of a group G is the subgroup containing only the identity element E. The trivial subgroup is a subset of every group and represents the smallest possible subgroup within a group. Although simple, the trivial subgroup plays a crucial role in the study of group theory and subgroup properties. Cyclic and group and subgroup. A cyclic group is a group generated by a single element denoted as A, where A is an element of the group. Subgroups of a cyclic group are also cyclic, generated by a single element, that is, a power of the generator of the parent group. Understanding cyclic groups and subgroups provides insights into the structure and properties of group with specific generating element. Order of a group and a subgroup. The order of a group G is the number of elements in the group. The order of the subgroup H of a group G is the element in the subgroup. The order of subgroup must divide the order of parent group, a property known as Lagrange's theorem. It states that the order of subgroup divides the order of the parent group. The theorem provides a fundamental result in group theory, establishing a relationship between the groups of and their subgroups order as important implications for understanding the structure and properties of group and subgroup. Normal subgroup. A subgroup H of a group G is normal if for every element G in H and H in H, the conjugative GHG in verse 1 is also in H. Normal subgroup plays a crucial role in group theory. They particularly in the context of cohesion group and group or more. The concepts of normal subgroup leads to the classification of groups and the study of group extinctions. Quotient group. Given a group G under normal subgroup G and the quotient group G by n consists of cosets of n in G with the operation defined as an bn is equal to abn. Quotient group provide a way to study the structure of groups by examining the relationships between the groups, its normal subgroup and the cosets. Understanding quotient group also allows for the exploration of group isomerism and group homomorphism. Isomorphism theorem it states that if null belongs to G determines H in a group homomorphism with kernel K, then G bar K is isomorphic to the image of null in H. The theorem established a connection between the structure of a group, its subgroups, and the homomorphism between groups. Isomorphism theorems plays a key role in group theory, providing a deeper understanding of group structures and properties. Direct product of groups. The direct products of two groups G and H denotes as G into H is the set of all ordered pairs with the operation defined composite wise. Direct products allows for the construction of new groups for existing group, preserving the individual property of their own original groups. Understanding direct property helps in studying the structure of groups and subgroups with complex relationships. Automorphism of a group. An automorphism of a group G is an automorphism for H to itself denoted as aut G. Automorphisms preserves the group structure and properties, mapping elements to elements while maintaining the group operations. The study of automorphism provides into the symmetric and transformation of groups and subgroups. Centralization and normalization subgroups. The centralization of an element in a group G is a set of elements that commute with A, denoted as C of A. The normalizer of a subgroup H in a group G is a set of elements that normalize H, denoted as N of H. Centralizer and normalizer subgroups play important role in understanding the structure and symmetrics of groups and subgroups. Group action. Group action of a group G on set X is a function that assigns to each element G in G and each element X in X a unique element Gx in X, satisfying certain properties. Group action provide a way to study the symmetrics and transformation of sets under group elements. Understanding group action leads to the concept of permutation groups and the study of group representation. Conjugacy classes of an element A is the group G in the set of all elements. Classes partition the group into equivalence classes based on the conjugation relation. The study of conjugate classes offers insights into the structure and properties of groups and subgroups. Conclusion. Properties of groups and subgroup, such as closure, associativity, identity, and inverse, are essential for understanding the structure and behavior of abstract algebraic system. Subgroups inherit properties from the parent group, allowing for the explosion of group structures at different levels of complexity. The study of group theory and subgroup property is a rich and diverse field with application in mathematics, physics, cryptography, and other disciplines. That's it for today, and thank you. Please do like the video.